Hello everyone, welcome to another video on debugging the agentic workflows. So we have already covered a lot of videos on the agentic workflows, and we have also discussed a lot of concepts before. Using those concepts, you can now build some complex agentic workflows. But now, since we are capable of building complex agentic workflows, it is important for us to understand how you can debug these agentic workflows. Alright, so in this video, we'll talk about debugging, how you can debug your complex workflows, how you can use the concept of threads and checkpoints to do that, right? And the thing is, things can easily go wrong while building complex agentic workflows, and in such situations, we should be able to debug our workflows efficiently. Now, we'll talk about two things in this video. The first is the thread, how you can assign threads, which is a unique ID, to the checkpoints, which is saved by a checkpointer. So how you can basically what we will understand is that how you can assign a thread to a particular state of a workflow execution. So when you execute a workflow, before executing it, you can assign it to a thread so that all the checkpoints of a workflow can be assigned to that particular thread. We'll also discuss about checkpoints, where we will understand how you can set up checkpoints at every point of your workflow. Now, everyone has played a lot of video games, right? And in those video games, what we used to do is that when we have completed or when we have reached at a certain level, we can save that game, or basically we can add a checkpoint that, hey, if I have to restart, I don't have to restart from the start, I can restart from this particular checkpoint. While debugging our workflows, we'll use the same concept of checkpoints, meaning that in our workflow at multiple places we'll add the checkpoints where we can go and we can understand what was the state of our workflow was at that particular time at that checkpoint, and then we can move from one checkpoint to another to understand what happened, and in this way we can debug that what went wrong at what point of time. Now this is the idea, and this is the concept which we're trying to understand. Also, going forward, we'll implement a small agentic workflow where we will understand how we can debug them with using threads and checkpoints. This is how the execution or the debugging workflow will look like. Here we have a agentic workflow with 4 steps. This is a very high level design. We have an agentic workflow which has 4 steps, or you can say that it's a LangGraph based agentic workflow which has 4 nodes, right? These nodes are identified by steps: step 1, step 2, step 3, and step 4. Now we have a location symbol, or we have a checkpoint symbol, meaning that we are adding checkpoints at each nodes. And when a checkpoint is added to a node, it has the snapshot of the state of that particular node. So if I executed this workflow and something went wrong on step 2, or something went wrong in this entire workflow and we don't know where it went wrong, I can go through the checkpoints and I can read, or I can understand the state snapshot, or I can basically debug the state snapshot. I can go to the step 1 and I can see that what was the state snapshot was at this point of time, and then I can see and I can understand that is everything okay or not, right? If everything is okay, I can go to the next snapshot, I can go to the next checkpoint which is at step 2, and I can see the state snapshot and I can understand that okay, basically I can pause and debug and I can understand that okay, what was the state snapshot and was it correct or not. And if I find that okay, this state snapshot doesn't look good, I think there is something fishy going on here, I have found the issue. So I can say that something went wrong on step 2, and then I can understand the code at what has happened in step 2, or what code I have written for executing node 2, and I can understand that what is happening here. Is it like my large language model is giving me something unexpected, or I'm handling something unexpected, or I am like my code is faulty, whatever the reason is. But this these features allow us to debug the workflows, complex workflows, and understand what has happened at what place and what should be the next step, right? So we'll use this pause and debug mechanism with the help of the checkpoints and threads to understand how we can debug these workflows. This is the overall agenda of the video. Now, talking about the agenda, let me lay out the agenda one by one. We'll discuss how you can debug your complex workflows. We will discuss the concept of threads. We'll discuss the concept of checkpoints. We'll discuss how you can debug your agentic workflows through an example. So I have an agentic workflow on We'll build an agentic workflow on LangChain actually using LangGraph, and we'll understand how we can debug these workflows, right? And at the end, we'll see the conclusion that what has happened. What, like, was our debugging process helpful? Did we like achieved any ease in debugging with these concepts or not? So now we have discussed the agenda, it's time to look at the concepts one by one. So as discussed in the agenda, we have already discussed how, like, why we will be using the debugging framework and how we will be using the debugging framework, right? So we'll be using the debugging framework with the help of checkpoints and threads to debug the complex workflows. That's we have already covered. Now what we can do is that there are two concepts which we have to cover, that is threads and the checkpoints. So we'll start with threads and then we'll move on to the checkpoints, and then we will do a code walkthrough to understand how you can implement all these things to debug your workflows. Now let's start with the thread. So what is thread? By the definition, it says it contains the accumulated state of a sequence of runs. So when a run is executed, the state of the underlying graph will be persisted to the thread, right? So what we can say is that a thread holds all the execution, or basically a thread is mapped to all the checkpoints in a graph execution. So if I have an agentic workflow or an agentic graph which I want to execute, I can start the execution, but before that I can map that execution to a thread. So I can say that, hey, this is a thread with ID 1, and when I run the workflow, all my checkpoints in the workflow, which I'll further use for debugging, should be mapped to this thread, so that if I have multiple executions, then I can handle them, or basically I can map them to multiple different threads, and I can understand, or I can execute different execution of the workflows independently. That is the whole concept. So we'll not go into the multi-thread execution in this video right now. We'll keep it to a single threaded execution for the sake of the simplicity, so that we can understand the debugging workflow properly. So what is happening here? Again, we have a agentic workflow with 4 nodes that is defined by 4 steps. At each steps, we are setting up the checkpoints. So we have already created multiple workflows before in the previous videos, and in those videos we have run the workflow, but we haven't added the checkpoints. So in order to add the checkpoints, we have to make some changes in the configuration while running the graph workflows, right? And that's what we're gonna do in this one. So in all the previous videos we haven't done it, but we will do in this one. We'll enable the checkpoints while executing the graph in this example, right? So we have a 4-step agentic workflows. Every step is mapped to a checkpoint. So this will help us to understand what has happened at every step. So if we want to understand what has happened at step 1, we can go to that step and we can go to that checkpoint state, and we can understand the state of the checkpoints. Now you can see that all the steps are mapped to their own checkpoints, and these checkpoints have their own IDs. So we have 4 steps, that is 4 nodes. These nodes are mapped to their individual checkpoints. With checkpoint ID 1, step 2 is mapped to a checkpoint ID 2, step 3 is mapped to a checkpoint ID 3, and step 4 is mapped to a checkpoint ID 4. But the interesting thing to notice here is that all these checkpoints is for a single workflow execution. So we have executed this entire workflow once, and this workflow execution has produced us 4 checkpoints for 4 of the nodes, but all these checkpoints are for a single workflow execution, right? And that is why this execution is mapped to one thread with thread ID 1, and that is why all these 4 checkpoints is mapped to a single thread with the thread ID 1. That's what I wanted to show via this diagram. So you can see a single thread ID with a thread ID 1 is mapped to all the checkpoints with different IDs in a single workflow execution, right? So that is the concept of thread. Now let's understand the concept of the checkpoints. So again, I have a different diagram which is similar to the previous one itself. So this is the checkpoints. Again, we have agentic workflow of 4 nodes, meaning which is defined by 4 steps. At every step, we have a checkpoint mapped. So each step is mapped to a different checkpoint IDs, and every checkpoint ID has a snapshot state. Now this is something which we should know, that every checkpoint holds some information about that particular state of the graph or the workflow. So step 1, that is the node 1, will have the checkpoint state of that node will have the information about the runs or about the state of that particular node. So here you can see that these are the information which is there in the checkpoint or the snapshot state. First is the value. So value will be nothing but it is the value of your shared state. Whatever values of the shared state will be at that current point of time while your graph execution reached step 1, this value will be there, or basically the snapshot of that value will be stored here. Next, this will determine what should be the next node. So since you are at step 1, probably the next will be step 2, meaning at this snapshot state the graph execution is moving to step 2, and then it will have a checkpoint ID which will be a unique identifier for this particular checkpoint or this particular snapshot state, right? It will have multiple other information as well, but I have highlighted the important ones which us needs to basically which we need to care about, right? And these information will be there in every snapshot state. I haven't shown all these information on all the state. I have only focused on the value pieces, but the next and the checkpoint ID and all the other information will also be there in the other snapshot state, and those value will have their respected values for those checkpoints, right? Now coming to the checkpoint ID 2, you can see in the checkpoint ID 1, the snapshot state, the value in the snapshot state, only key 1 has a value 1 assigned. Key 2 and key 3 is empty, meaning step 1 was doing something to fill the value of the key 1, right? It did something and it set the value of key 1 to value 1, right? Now the graph execution moved to the second checkpoint, and from here we can debug that, okay, checkpoint ID, the node 2 has filled up the second key, that is key 2, with value 2. And again going forward, the node 3, that is step 3, has filled another key, that is key 3, with value 3. And again moving forward, the step 4, that is node 4, has a checkpoint ID 4, and this node is responsible for again updating the same key, key 3, but with a different value. So here it is currently value 3, but I can have something like value 3.1 that says that, okay, this checkpoint ID is again updating the value of the key 3 after doing something, and the value updated value is value 3.1. Now you can see the detailed snapshot and understand that, okay, how the graph execution went and how your state changed. And in that place, if you think that something went wrong at some point of time, you can identify through the snapshot state and you can take your measures to avoid these errors, right? So this is the whole concept, and this is the whole debugging framework which will follow to debug our workflows. Cool. So this is the concept which I wanted to discuss on threads and checkpoints. Now moving forward, we'll go through the code walkthrough. And in the code walkthrough, what I have for this video is a very small workflow, agentic workflow built on LangChain's LangGraph framework. We'll introduce the concept of checkpoints and thread in that workflow, and we'll try to debug it. So I have introduced a small piece of error in that workflow, which we'll see when I'll execute that workflow, and we'll see that, okay, things are not going according to our plan, and what should be our next step. So the next step should be to debug that workflow, and we'll understand how you can use checkpoints and threads to debug those workflows. So we are at the code walkthrough. I have built a basic workflow as I mentioned earlier, and this workflow has a small error which we'll see when we execute it, and we'll see that things are not going according to what we thought it should. So let's import all the open source libraries before we go ahead. Let me load the environment variables, and then we can define the shared state. So any workflow or any workflow on LangGraph we need to define a shared state that will gonna tell you that how the information passes from one node to another. Now we have a shared state with two fields, that is DSA topics and system design topics. So at a high level, what we are doing is that we have an agentic workflow that has two nodes. The first node will give us the top 5 DSA topics, which is currently important for software engineering interviews in year 2025, right? And there is a second node which will similarly give us 5 most important system design topic for software engineering interviews in 2025. Now what we expect is that at the end of the workflow execution, we should get a response. In the response, we'll get the shared state, and in the response we should have DSA topics the DSA topics field should have a list of 5 DSA topics, and the system design topics field should have a list of 5 system design topics. That is very clear. So that's why it's a very simple workflow, because the structure of the workflow and what we aim to achieve from the workflow is quite simple. But there is a small error which we'll understand and we'll try to debug it, right? Let's run this one. Okay, we have run the shared state. We have defined a method that is parse model response. So it is basically what it does is that we get a response. We have told the large language model to give a response as a comma separated values of the topics. So what we'll do is that we're gonna convert them into list by splitting the string by commas and converting it into list. That's a very simple one-liner method probably. Now we have our first node, that is find relevant DSA topics. So as a query suggests, can you provide top 5 DSA topics to master for software engineering interviews in 2025? Please only return the DSA topics, comma separated, no other details is needed. Meaning we don't want any other information from the model. We don't want the description of the DSA topic or the model's thought on which topic is important or not. We simply want 5 DSA topic which is important with the perspective of software engineering interviews in 2025, and we want these topics comma separated. So while returning, these should be comma separated. The model we are using for the current demo is OpenAI's GPT-4o, right? And there is a query. We'll invoke the model with the query and we'll get the response. When we get the response, we will pass the content of the response to the parse model, which will convert the comma separated string of the topics into the list, and that's what we want. And then what we'll do is that we'll assign that list to our shared state. So currently in this node we are getting the DSA topics, so we'll initialize or we'll set the DSA topics to the response of the model and we'll keep the system design topics empty, and that makes sense actually. So I can run this one. Now we will go to the second node, that is find relevant system design topic. It is very similar to the previous node. The only difference is instead of DSA topics, it will give us system design topic. And by DSA, I mean data structure and algorithms. So it will give 5 system design topic. It uses the same OpenAI's GPT-4o model. It will give us the response and will send the response through the same method, parse model response, because this also returns comma separated topics. And we will save or will set the system design topics field of this in this method or in this node. And since we are not handling DSA topics in this node, we are keeping it as empty, and then we can run this one. Now these are the 2 nodes which we ran. Now we have defined these 2 nodes. Now we'll define our graph. Now the build graph is very similar to what we used in our previous video to build the workflows. The workflow has the shared state which we defined above. The workflow will add nodes first. So the first thing we do is that we define the nodes. We have 2 nodes, so I can quickly define these 2 here, and then I'll set up the edges. Now this workflow is a serial workflow. So it will start, it will go to the DSA topic, then it will go to the system design topic, and then it will end. So start, pick the DSA topic from model, pick the system design topics from model, and then end, right? And then there are some initial things which I'll do in order to initiate or in order to implement our debugging framework. So what we are doing is that we are setting up checkpoints. Checkpoints can be set up using the in-memory saver, which is present in the LangChain library. So it's very simple. It's a 2-line code. Initially what we used to do, we used to simply compile the workflow, but this time we'll compile the workflow with our checkpointer defined. So this what we'll do is that it will save these checkpoints in its memory, right? So it will initialize the memory, and at each step it will save the checkpoints of the workflow execution so that we can debug it. And as I mentioned earlier, the entire workflow execution should be mapped to a thread. So this will initiate a thread with a thread ID 1 and will pass that when we invoke the graph, right? So at the time of invoking the graph, we'll pass this config that will define the thread ID. And since every graph invoke or graph execution is mapped to one thread, that's why passing the config at the time of invoking the graph makes sense. So if we are invoking graph multiple times, we can associate these executions to multiple different threads, and then we can get the checkpoints for those different threads and we can debug them independently, right? That is the idea. And then at the end we'll get the response, and along with the response we'll also return the graph and the config, right? We'll return the graph because we will need to debug it if there is any error, and config because we need to understand for which execution we are debugging. Config will have that thread ID stored. So for the so if we have two configs, meaning if we have two thread, we can debug that independently with the help of the two different configs which we will have. So I guess that is sorted. I can run this one. So this method runs. Now we have defined everything which we need for our graph. We can see what the response is now. So I can run the graph and this will gonna give me some response. Now I have the response, but the response is not what we thought. We thought that we'll have some DSA topics and system design topics, but here we can see that the DSA topic is empty, but we have system design topic. Now, since this is a simple graph, I can easily go ahead and I can go through the code and I can understand where we are going wrong. But in case of complex workflows where maybe you have suppose 20-30 nodes and multiple edges connecting them, it's very difficult to go through the code base and understand what is going wrong. A better and efficient way is to go through the checkpoints while the workflow executed. So we want to understand where did things went wrong, because we have set the DSA topics here. This node was supposed to give me the DSA topic. Why am I not getting the DSA topic here? Why it is empty here? That is the whole question, and that's what we are trying to understand. In order to understand, we can get the snapshot. We previously mentioned that while setting up the checkpoints, these checkpoints will have the state of the snapshot stored at every checkpoint. So I can get the snapshot with the help of the config which we have. So I can run this and this will give me all the snapshot of the workflow execution. I can show you one of the snapshot. So let me show you the first snapshot, because we have 2 to 3 nodes. We have 2 nodes here, so we can expect multiple snapshot. So the snapshot will look like this. The state snapshot value. First is the values which we mentioned earlier as well in the start of the video, that values will store the content of your shared state, and that's what it is currently storing. Next will define which node it should hit next. Config should have multiple other configurables. First you can see is that it is mapped to a thread ID, which is the thread ID 1, right? It has a checkpoint ID, which is a unique checkpoint ID defined by the graph. Every checkpoint will have the unique checkpoint ID, but all these snapshot will map to the same thread. So if I get to like see another snapshot, I can see this has different data, but at the end of the day the thread ID is same. All these execution, all these snapshot states, all these checkpoints are mapped to a single thread ID, right? Now we can debug this. So one thing to note is that when we get the snapshot from LangChain or from the LangGraph, these snapshots are arranged in a descending order, meaning the first snapshot will be of the last node and the bottommost snapshot will be of the first node. So we can reverse it to understand what has happened from start to end. So the list, the snapshot has been returned is from end to start going back. What we can do is that we can reverse it and we can see that what has happened from first node to the last node. So that's what I'm doing here. I'm reversing it. I'm reversing the list of snapshots, and then I can understand that what has happened here. So I can see when I run this, we have a snapshot details. This is the first node. So the first node goes to the start node. That's all right. Then the start node goes to the find relevant DSA topics. That's all right. This is expected. And then when we reach to the find relevant DSA topics, we will expect that we should have some DSA topics. So once this was executed and we move to another snapshot, I can see that I have some DSA topic, and that is expected because this node was expected to give us some DSA topic. So this is expected, but we don't have a system design topic. That is also expected because we haven't reached to the find relevant system design topic. Now when I go to this node, I can see that I have relevant system design topic, but I don't have any DSA topic. Now this is the problem because find relevant system design topic, this node is making our DSA topic empty. Basically it is setting the DSA topic empty, which was previously set by the find relevant DSA topics node. So this is a faulty snapshot and this node is faulty. We need to see, now we know where the problem exists. We can go to that particular node and see what is happening here. So if I'll go to this particular node, find relevant system design topic, I can see that I am returning my state, but while returning the state, I am making this DSA topic empty, and that we shouldn't do, because when I give the state to the LangGraph, it doesn't combine it the way we want, because we don't have any reducers for the DSA topic. So it is directly setting the value of the DSA topic which was returned by the node. So what I can do, instead of that, I will already have a shared state. I'll reuse that shared state, and I'll not modify whatever information is already there. I'll just add my system design topic and I'll go away with it. So what I can do is that I can just remove this and I can comment this line. So what it will do is that in the existing shared state which we are getting from the DSA topic, so this shared state will have the DSA topic. I just have to add my system design topic, and I don't have to make any other modification in the shared state, and I can directly return the shared state here. Now I can run this to update the definition of this method. And now when I'll go ahead and I'll run this particular code lines, then I can see that my graph will be built and I'll get the response, and this time I'll get the response the way we want. We'll have DSA topics as well, and we'll have the topmost system design topics as well, right? And now I can see, I can get the snapshots from here, and I can see what the snapshots will be, right? So these are the snapshots. So this is the first snapshot. Basically I can reverse it and I can understand what are the snapshots which we have currently. So we have 4 snapshots, starting with the start node, going to the DSA topic node. From the DSA topic node, it is going to the system design topic node, and at that point we have some DSA topics that is expected, and then we are going to the system design topic, and here we have the DSA topic and the system design topic as well, and this final response is being returned to us. And now our workflow is executing the way we want. We have debugged the error and we have correctly identified it and fixed it. This is how you actually fix a workflow with the help of these threads and checkpoints. So this was the end on debugging your agentic workflows. We discussed the concepts of threads and checkpoints to understand how you can debug your complex workflows efficiently. Now, if you want to refer to the code base which we went in the code walkthrough part, you can always go through my AI Engineering 101 repo, which is present on the GitHub. The link to the repo is there in the video description. And if you like this video, give it a like, share it with others, and subscribe to the channel if you think that this is helping you to become a better AI engineer.